Hello, I am Mrs. Lesh, and I am here with Mrs. Armentrout, and today our goal is to be working on multi-step inequalities. We're going to look at a sample here. The reason why it's multi-step is that there are not one, but two operations with our variable. So to isolate our variable, there'll be multi-steps. We're going to write down the steps, so I'm going to go through them and then you can pause the video and write them in your notes. Step number 1, we are going to be rewriting to eliminate subtraction or division. For example, in this problem we have subtraction, so we would rewrite using KFC, keep, flip, change to the opposite.
In the second step, we are going to isolate the variable. Now, here's where you need to pay close attention. To solve a multi-step equation, it is crucial that you go in this order. Just like when we solved two-step equations, we started by adding the opposite. Then we would multiply or divide to get the variable alone. We're going to do that in the same fashion, but you have to notice that if we multiply or divide by a negative number, we have our red alert. Sorry, no silly hats this time. Remember, that means that we switch the sign. Only when you multiply or divide by a negative.
And the last step, as always, we're going to be writing our solution set. When we write it, we're always going to write the variable first, our inequality, and then our number last.
Let's take a look at an example. Remember that when you are solving inequalities, there are 3 things we need to see on your paper. We need to see you solve with the solution set. We need to see you graph the solution set, and very important, we need to see the check. What you can do to remember that check is you can start by, before you even solve the problem, go ahead and recopy it, but instead of the variable, put a little box to insert a number after you've solved it. So we've got 6 times something, and 15 is going to be greater than 9 to check if you solved it correctly.
In our problem over here, we're going to be isolating our variable. I have 2 operations. I'm multiplying by 6 and I'm adding 5. So remember, the order is important. I have to eliminate my addition first. So I'm going to add the opposite. Opposite of positive 5, or 15, is negative 15. On the other side, I will also add the opposite, negative 15. Positive 15 and negative 15 are my 0 pairs. They are now eliminated. 6 times n is remaining. I'm going to recopy my same inequality symbol. I now have 9 plus negative 15 because the signs are not the same. I'm going to find the difference between them, which is 6. I have more negative numbers, so that means I have negative 6. Second step. I am multiplying by 6. So to eliminate the multiplication, I will divide by the same number. So I will divide by 6. And on the other side, I will also divide by 6. 6 divided by 6 is 1. That leaves me with my variable remaining. And negative 6 divided by 6 is negative 1. The signs are not the same. It's going to be negative. If the signs are the same, your product will be quotient will be positive. Down below, whatever is in my solution, I'm going to write in the center of my graph.
Notice that Mrs. Lesh did not flip the sign. Even though there was a negative up here, she divided by a positive. So our inequality stays the same for our solution set. Put a negative 1 in the center, and then remember you want 2 in either direction. Making sure that you choose the same interval. We're going to increase by 1, so as I get larger, the next number would be 0, then a positive 1. As I go to the left, when I get smaller, negative 2, negative 3. We're going to circle above our value of -1 because our variable is first and is greater than -1. It points me in the direction to go to the right. And so I'm dealing with numbers to the right of -1, but not including -1 because the numbers have to be larger than -1. In our check, we're going to pick a value that is underneath the arrow. It can be the values that we see or beyond. I'm going to choose a +1.
Oh, I was thinking 0 because that would make the math easy.
Should we do that?
Let's do 0.
Oh, you're so good. All right, let's do 0. 6 times 0 is 0. That does make it a lot easier. And 15 means that we have 15 is greater than 9. Since that is true, we know we are on the right track.
In our next equation, our inequality, we have -3 minus 4 times a is less than or equal to 15. I am going to do some rewriting to eliminate the subtraction. So I am going to flip it to addition, and change it to its opposite, which would be -4. Solving my steps, I am multiplying by -4. I am adding -3. We will undo our addition first. The opposite of -3 is +3, so I'll add 3 to both sides. I have -3 and +3. My 0 pairs are eliminated. I have -4 times a remaining. And then 15 plus 3, I have 18.
Because we see that we want to isolate the a here, this variable, we are multiplying by a -4. Now, I remember that when I multiply or divide by a negative, then I need to flip the sign. Because I'm multiplying by -4, to undo that, I'm going to divide both sides by a -4. I like to circle my inequality so that when I'm solving it out, I don't forget about the red alert. So this cancels out because a -4 divided by a -4 is just going to leave me with the 1a. So I bring that 1a down. Because I have a red alert, I'm going to flip that sign right away. I'm going to make it red.
I'll make it red
like that.
intro.
Now, 18 divided by a -4. I know that this is going to end up in a rational number because nothing evenly will work. 4 times nothing is going to evenly give me 18. So I'm going to sneak over here and I'm going to divide. I know the closest I can get is 4. And I'm left with 2. So 4 and 2/4, which I know is 4 1/2. Now, if you do this on your calculator, you might pop up with a decimal. Because I don't have any rational numbers here, I can write it as a fraction or a decimal. So you might have a -4 and 1/2, or you might have a -4.5. Either would be an acceptable answer because it's the same value.
Down in our graph, I'm going to take one of these values, either the rational number or the decimal form. I'm going to write -4 and 1/2 in the center. I need to choose an interval to count by. I could count by ones, I could count by halves. I'm going to count by halves. Remember, with negative numbers, we're thinking of temperatures that are getting warmer. So we're going to have -4, -3.5. In the opposite direction, -5, -5.5. I'm going to put a circle above my -4.5. I notice in my inequality it can also be equal to -4.5, so I'm going to color my circle in. And it's all the numbers that are greater, also my arrows pointing to the right. So I will draw that in.
With my check, remember you want to go back to your original problem. Some of you may have already written this in. So I have -3 minus 4 times whatever value I'm going to select is less than or equal to 15. So I really feel like working with a whole number is going to be easier, so I'm going to pop in there a -4. So order of operations tells me that a negative 4 times a negative 4 is going to give me a positive 16 because I have same signs. Bring down my negative 3. Negative 3 and 16, different signs, find the difference. So I have 13, which would be positive because 16 more positives. So this is going to be 13 is less than or equal to 15, which is true.
All right, last problem, Mrs. Armentrout.
All right.
We have 10 is less than 4/5 times b plus 2. So we are going to be isolating our variable. I'm multiplying by 4/5, adding 2. I'm going to undo the addition first. Adding the opposite is negative 2, and on the other side, I will also add negative 2. So 10 plus negative 2 is 8. Opposites are eliminated. I am left with 4/5 times b.
All right, so we have to get rid of that 4/5. And since we know that 4/5 times b, to undo that, we're going to multiply by the reciprocal. So we're going to multiply both sides by 5/4. This is going to cancel out because 5/4 times 4/5 is going to equal 20/20 or 1. So we're just left with b.
Oh, Mrs. Armentrout, I have a whole number and a fraction. What will I do?
You are definitely going to want to make that 8 look like a fraction. All right. Now you have a choice. You can multiply across, and then divide, or you can look diagonally to see if you can cross simplify. I'm noticing a 4 and an 8, which would easily be simplified if we divide both of those by 4.
Okay, factor of 4. Divide by 4 is 1. 8 divided by 4 is 2. I'm going to circle my numbers that are left just so I can find them.
And so 5 times 2 is going to be 10. Well, that's not showing up. And 1 times 1 is going to be 1, which simply means that we have 10 is less than b. But notice that we do not want our variable second. So the last step is always make sure your variable is written first, because it reads, if we start with the variable and we go this way, it reads b is greater than 10. That is how it should read when we write it. So b is greater than 10. Notice we had no red alerts, which is cool, saves us a little step. We're going to go ahead and put our 10 in the center. Those whole numbers are nice. We're going to go up by intervals of 1. Circle our 10. It doesn't get filled in because it is not also equal to 10. B would be values that are greater than 10. So we're going to go to the right.
All right, Mrs. Armentrout, now when we do our check, I'm looking and I realize when I put a number in here, I'm going to have to take that whole number in fraction form. I can find a number that is a multiple of 5. It will make the arithmetic easier. 11 is not a multiple of 5. 12 is not. But if I kept counting, 13 is not, 14 is not, 15 is. So let's use 15.
All right. Notice we can't use 10 because it's not colored in. So 15 it is. Because we have numbers that can be easily simplified, I'm going to divide both of these by 5, giving me a 1 over here and a 3 over here. So, repeating the process, 4 times 3 is 12 over 1, which would just be 12, because 12 divided by 1 is 12. So I'm going to bring down my plus 2. I'm going to bring down the rest of my inequality. 12 plus 2 is 14. And 10 is indeed less than 14. So I know I've done this correct. By the way, if this step does not come out correct, you want to go backwards and check. Did I just simply go in the wrong direction? Because sometimes if you just plug in a number in the opposite direction, it will make your inequality true. And that's a simple mistake that you can fix. All right, on to practice problems.